All right, gang, didn't start the recording early enough. We missed 20 minutes of lecture. I apologize for that. What you're going to want to do is read this section real carefully, and then we will come back and hit the idea again. So go and read 3.7 in the book. The PowerPoints don't quite say enough about it. Specifically what we're doing is we're using the IO manipulators, and we're using setW in order to control the width of what we just printed. And so, by the way, in the code, the place where I was running into, or where we were getting problems with typos and stuff like that, is that I formatted this different than I have in the past. And so then when I came over and I helped you, I changed the formatting to look like this. Don't do this for everybody who got it working. I'm just showing you what I could have done, and people would not have had the same problem typing it in. Right, that does the exact same thing. You don't use set W when you're printing out an end of line marker. All right, and don't forget that X++ at the bottom. Okay, and those of y'all who didn't get to see the rest of it, this will be in the notes if you want to inspect it. But for now, I'm just going to ignore the rest of that, and we're going to go on to a new chapter, or new idea. So if you're using setW, you have to include IOManip, # include IOManip. There's another one about floating point numbers. Fixed and set precision. Set precision controls how many digits of precision. Like if you want to see 3 decimal points after every floating point number, you can do set precision 3. If you want to control it so that you have 5 places, you do set precision 5. All of these require the IOManip file. setW, you have to keep using over and over and over in order to get it to work. That's why we had to use setW every single time. And did it have to be the same number each time? No. If I wanted one column 4 characters wide, and I wanted one 5, and I wanted one 7, then I would do setW4, setW5, and setW7. So, as far as our notes go, I guess what I'm going to say is # include IOManip for formatting data. setW X pads the next item printed to X number of spaces. Set precision Y sets the format of floating point numbers so that Y digits after the decimal point are displayed. setW has to be called every time you want to do it. Set precision you only do once until you want it to change. So if we were going to change all these to set the precisions in our code, we would have set precision only once in it, rather than once every piece of data. And okay, for you guys who are typing at home, I am going to go ahead and just set the screen here, and you can go ahead and type it in and watch it run. But this stuff gets annoying here, and if you can't get it to work, just comment it out and run along your merry way. So here's the first chunk of the code. Pause it, then scroll down and type in the rest of the code. If you get it to work, great. If you don't, check the notes real carefully and see if you can figure out what you did wrong, and barring that, you can comment it out. I do want you to remember setW has to be called every time you want to do it, and set precision you call only once. And we'll have reason to use set precision when we're using floating point numbers and when we're using loops. These are the natural uses for setW and set precision. And there's another one, left and right. If you do arrow, arrow left, it will cause the next output to be left justified. If you do arrow, arrow right, it will cause the output to be right justified. So we could modify our columns. Here's what our code looked like when we ran it. We could have modified it so that it was all right justified rather than left. Now that requires like 9 changes, so I'm not going to do it, but we could do that. That is right justified, so that we could left justify. I don't remember which I said. Alright, working with characters and string objects. We can use getLine, we talked about that, to get an entire line rather than tokenizing it so that it only gets the first piece of information out of it. And then you can use cin.get to get a single character. If you're going to use cin.get, then you ought to flush the buffer first by using cin.ignore. And this number can be very large if you want to make sure that it's ignoring and data sent to it. If you run into a problem where you're calling cin.get and it's not waiting for the character, then add cin.ignore in front of it. And as a matter of fact, it wouldn't be a bad idea just to always use cin.ignore before your cin.get, just as a matter of course. I'm not coming up with a real strong reason to talk about the math functions because I can't think of some cool formulas to use that use these. You know, I always do surface areas and volumes and stuff like that rather than sine, cosine, and tangent. Square root is pretty neat, but you can always just take something to the power of 1/2 in order to get a square root. So square root, POW x comma 0.5 would take the square root of the number without having a square root function. ABS is nice though. You want to get the absolute value of something. Let's play with that just a little bit. I'm going to come down here and I want to see if two numbers are close enough to each other. So why not doubles? Double D1 is equal to 1.0 divided by 3. Double D2 is equal to 2.01 divided by 6. Those numbers ought to be pretty close, right? But they're not going to be exact. So I want to figure out the difference between the two. So here's what I'm going to do. I'm going to do double delta. And there's another term for this as well, but if you've done physics, you've probably heard the term delta. Delta is just the difference between one and the other value. So double delta is equal to D1 minus D2. And let's print that delta out. So C out, and then the word delta, and then the arrow, arrow. So C out, arrow, arrow, quote, delta equals, end quote, arrow, arrow, delta, arrow, arrow, ENDL. That should show us the difference between those two values. All right, and that's the difference between them. What if I want to judge whether that difference is like within 1%, like 0.001? Here's what I could do. If delta is less than 0.01, then we're going to see out the phrase close enough. So if, parentheses, delta less than 0.01, see out, arrow, arrow, close enough, backslash n, end quote. Now I have a mistake in my code. It is going to print close enough. Close enough. Difference is smaller than 1%. Maybe you see where I'm going with this though. What if this was like 20 divided by 6? rather than 2.01 divided by 6. So I'm going to make it 22.1. I'm going to come back up to this D2 line and change it to 22.1, and I'm going to run it. Now those numbers are not going to be close at all. Delta is going to be very large, right? The delta is 3.333, and it still says it's close enough. Now why is that? It's because delta is negative. We want to take the absolute value of delta in order to do our comparison. So why don't we add that on here? If the absolute value, well, you see the line that I'm changing is the if statement. I should probably put it on its own variable. Never mind. I'm undoing that, and I'm going to do delta is equal to ABS parentheses delta. And I added that before my if statement. Now it said I had to include CMath in order to get that to work, but Microsoft C is kind of funny. We didn't have to include CMath, and notice that it's no longer saying close enough. Let's go back to our original calculation. I'm going to take that 22.01 and just change it back to 2.01, and then I'm going to stop so that people can catch back up. Alrighty, and now the delta is less than 1. I should have printed it out after I changed the after I took the absolute value of it, so maybe I'll swap the position of those two statements. You see where I print it? Cut that and paste it to after where we take the absolute value. Then it's time to pause because I've messed up the code enough to make it hard to follow. Okay, so I'm going to take that cout statement, cout delta, and paste it to after our calculation. So that's the line that I just changed is right there, and like right there. I swapped those two lines. All right, just out of curiosity, I want to see whether sine, cosine, and tangent and square root really do require CMath. How weird Microsoft C is. Okay, so I'm just going to type in some stuff. You don't have to type it in. Sine, cosine, tangent. I don't remember my math well enough to know if any of these are going to blow up. And then square root of 1. All right, let's run it. Okay, apparently the CMath library is already included by default, even though I don't have it up here in my headers. If you were using something other than Visual Studio, you would have to come up to the top and do # include CMath to get all that to work. So just to be correct, I'm going to go ahead and do that, # include CMath. And then I'm going to go over here and I'm going to Google Microsoft C++ CMath already included. Just doesn't say. I'm getting sick of Microsoft M when it auto includes headers. Yeah, I'm not going to bother with it. All right, more math functions. Here's the fun one. Rand. If we wanted to write some code that generates random numbers, you use the rand function. Well, there's more than one way to do it. But why do you like random numbers? Like in games, rolling dice, or, when Pac-Man was written, the ghosts always followed the exact same pattern. So people could develop patterns and then they could play Pac-Man for, as long as their stamina let them. Yes, sir?
So is this going to actually random unlike Python, or is it like?
No, there is no true random in any language.
Okay.
These are the question is are these actually random numbers as opposed to Python, which generates a simulation of a random number? No, these are simulations as well. Rand will return the same sequence of numbers every time unless you seed it with a different number. And so what people do, and I don't even think we had to do this in Python. I don't think we had to seed it. So what people do is they seed it with the current clock, right? The current number of seconds, because otherwise it'll return the same number every time. And we will prove that to ourselves. You know, so random numbers are nice because, like, you don't want your ghosts in Pac-Man always following the same exact path. So in later games, like Miss Pac-Man, they put some random number generation in there so that some of the ghosts behaved a little bit more randomly. So you couldn't just develop a pattern that you could do in your sleep. These require a different header file, cstand_lib. Now, just out of curiosity again, I'm going to see if rand requires. I'm going to delete those lines. These are pointless down here. They were just to prove a point. But how about rand? Rand parentheses 1. Too many arguments in function call. Oh. Okay, the rand function does not let you specify the largest value. So you do not give it a parameter. And again, I did not have to include C standard library. When I did that Google about it, it seemed to indicate that Microsoft is doing some auto-including business. But we're not going to do that. So I'm going to add some comments up here to my header that CMath is used for ABS, tangent, cosine, etc. Right? And then I'm going to add another line. # include arrow C stand lib. C std lib. And this one gives us rand and srand functions. And then we're going to go down and we're going to write a while loop that prints random numbers. So we good? I can scroll down? Somebody say no. Okay. So down here, I'm going to write another loop. We already had a counter called x, so I'm just going to reuse it. I'm going to set x equal to 1 again. And then while x is less than or equal to 10, we're going to print out 10 random numbers. Do not put a semicolon after a while statement ever, ever, ever. Just like if you put a semicolon after an if statement, it breaks it. And so let's get a random number. How about r for random? Int r is equal to rand, parentheses in parentheses, semicolon. And let's see out arrow, arrow, r, arrow, arrow, e, and dl. See out arrow, arrow, r, arrow, arrow, e, and dl. This should print out 10 random numbers.
No, you didn't.
And I didn't increment the counter, so it's just going lickety split. Okay. And then x plus plus. And put a semicolon after x plus plus. Alright. And there they go. I wonder what the largest random number it will generate is. That strikes me as an interesting enough problem that I want to modify our while loop to do that, to run like 1,000 times and find the largest random number that it will possibly generate.
Yeah, same random numbers.
Yeah, should be giving us the same random numbers every single time, which is boring. So we're going to have to seed it with a different seed. We could ask for the seed and then seed it with a different seed, or we could use the clock to give us a seed. Let's just ask for one. So before we get into our loop here, let's ask the user for the seed. See out arrow, arrow. What is our random seed? Question mark, space, end quote, semicolon. I didn't type semicolon, so all right. And then let's declare a variable for that. Int seed, and then cin arrow, arrow, seed. And then lastly, srand, parentheses seed. And it says that seed needed to be unsigned, which makes sense because you can't generate a random number with this thing. So I'm going to do unsigned int just to follow very strictly its requirements. Alright, and I did that before my loop that printed out the random numbers. So when I run it, it's going to ask for a seed, and if I enter the same seed, it's going to give me the same results every time, like the number 0. If I entered a seed of 0, it gave me 38. Does anybody remember what our first number was before we had a seed? I guess I could comment that out and find out. Pardon?
I think it was 41.
Okay, so obviously it wasn't seeding it with 0. I do not know what it was seeding it with. 1? Yeah, okay. So if you don't specify a seed, it starts with a 1. And the way pseudo-random numbers work is it's an algorithm that uses the last number it calculated to generate the next number. And so since it does that, it has to have a starting point. And that's what the seed indicator specifies. Now we would really want to convert that to like a number between 1 and 6 if you were rolling a 6-sided die, or a number between 1 and 20 if you're playing Pathfinder or D&D and you want to roll a 20-sided die. Now the best way I can think of to do that is just to modulus it by 20. So I'm going to do that. On the next line, I guess I'm after R is equal to RA and D. I'm going to do R equals R modulus 20. Make the number between 0 and 19. But that's boring, because what if I want it to be 1 to 20? I'm just going to have to add one more to it. So R plus plus. That would add one more to it. Now should we do that all in one fell swoop? Yeah, we probably ought to. So why don't we add, I'm going to delete that line, that R plus plus line, and I'm just going to say 1 plus R mod 20. What is our random seed? 12. And there we get some random numbers. Good enough. Pseudo-random numbers. You know, the NSA and people who write code-breaking software sometimes care very much about how their random numbers are generated, and they may go to a lot more trouble than just using the rand function that C gives them. And that's all we say about the random number generator. We could write a game, you know, the guessing game. How many of us have written the guessing game at least once? Well, Zach, you get to do it again because nobody else is raising their hand. All right, so what's the guessing game? I'm thinking of a number between 1 and 100. Take a guess. And you take a guess, and it tells you whether... Pardon me?
I was just thinking it was more complicated than that.
No, no. And then, you know, you guess 75, and it says, no, that was too low. And so you guess higher again. So we're going to do that. We're going to write a program that does that. The way our program is going to look is it's going to say, I am thinking of a number between 1 and 100. I'm going to take the quotes off. What is your guess? Question mark, and they're going to type in something. Whatever. And then it's going to say, no, that is not right. Guess again. And so you'll type in 50 or whatever. And it'll say, bingo, you got it. And then it'll say done. That's what our program's going to do. Now it's kind of lame, right? Because it's not telling you whether you need to guess higher or lower. So maybe we ought to change it so that instead of between 1 and 100, it's just between 1 and 10. So at most we have to make, 10 different guesses. So I'm going to do that. I'm going to change our little spec here so that this is how it works. So how are we going to do that? We're going to have a loop. And if we do our pseudocode, you know, what's our secret number? Our pseudocode, pick secret number randomly. Yeah. And then tell the user, thinking of a random number. What is your guess? Then we're going to input the random, or input the guess, and we're going to keep doing this while the guess is not equal to the secret number. While guess is not equal to secret number, guess, we will input the guess, and then we will check. If guess equals secret, then output bingo. Else output no. Guess again. And then we would want to read in another number. Input guess again. So that's our pseudocode for it. Not that we love pseudocode, but just letting you know where we're going with this so that as we're typing along, you can, you know where we're going with it. Okay, we already have code that knows how to pick secret numbers, and we know how to print, and we know how to write while loops. So let's do it. I'm going to scroll down right before our system pause. Let's pick our secret number. Int secret is equal to random. We should seed it. We still haven't established how to seed it from the clock, but I'm skipping that. Now let's declare a guess. Well, we haven't modified our secret to be between 1 and 10. So make secret between 1 and 10. So secret equals 1 plus secret modulus %10. Now let's declare our guess variable. Int guess, and we're going to assign it an initial value that's absolutely wrong and will always be wrong. I could give it 0. I'm just going to make it -1. We could make it 999. We could make it anything. Something so totally wrong that we're absolutely sure that the while loop will be entered. Now let's print a message out. Cout. I am thinking of a number between 1 and 10. \n, end quote. Now let's do our while. While, parentheses, guess not equal to secret. While, parentheses, guess, exclamation point, equal sign, secret. End parentheses, open brace. Alrighty, we need to ask them. Cout. What's your guess? Question mark. Space. End quote. Semicolon. Now let's read it into the guess variable. CIN arrow arrow guess. By the way, a common problem when I demonstrate this stuff is if I goof up and I put the srand, the seed function, in the loop along with the rand function, then since it keeps reseeding it, it just generates the same number over and over and over and over, like, you know, to print out 16 10 times or something like that. So you can have rand functions all through your code, but you only want to seed it once. All right, now let's check. If parentheses secret equal guess, then that's good news. So end parentheses, open curly brace, C out, arrow, arrow. Bingo, you got it. Backslash n. But if it's not right, we're going to display a message. So end arrow, or excuse me, end brace, and then else, open brace, C out, arrow, arrow. Nope. Try again. Backslash n, end quote, end parentheses. Nope, no end parentheses. All right. But yes, we need our end brace. Alrighty. Now I don't need to update anything. I don't need like X++ because this isn't a counter-based thing. I guess we could make it where you only have 10 guesses and it kicks you out if you don't get it right. This game is kind of lame because it's not telling you, how close you got, or, whether it's less than or greater than or anything like that. But it gives us an example of using a random number to get a game going. I'm going to take some spaces out so that I can get all of this on the screen at the same time. I know it makes it more difficult to read, and I'm going to move that comment to after the line. Okay, that is the entire thing on one page. The only thing that we're not seeing is where we used srand. Let's run it, see if it works. All right, what is our random seed? Well, it's 100. Prints out some random numbers. I'm thinking of a number between 1 and 10. What's your guess? 5. Nope, guess again. 4, 3, 2, 1. All right, that's suspicious. Not really. But I'm going to run it with a different seed and see if it picks the same random number. I should just make it print out the random number, right? Just for testing purposes. What's our random seed? 101. I'm thinking of another number. 1. Okay, good. It is different. 2, 3, 4. It was 4. All right. Game would be more fun if we didn't have to pick our seed. I don't think that this PowerPoint shows us how to initialize the seed with the result from the time function. So why don't we go and do that? Well, let's go and update our notes here. Use rand to get a random number. Use srand x to specify a seed, parentheses, starting value. These functions require the C standard library header file. If at first you don't know how to do it, you Google it. srand time. So the srand function sets the seed. Any value of the seed produces a different sequence. So we might want to use time, parentheses, null. Let's see if we can get this to work. We're going to have to figure out what the time function is in. So up here, before we generate our random number, let's seed it again. So above our, and then I better stop and make sure that everybody's caught up. Above int secret is equal to rand, srand, parentheses, time, parentheses, null, in parentheses, in parentheses. Except take that null away and replace it with caps, null and caps. All right, that seems to work. Seed based on clock. It's based on the number of seconds since midnight. And so unless you just happen to run this program once every day at the same exact millisecond or whatever, then it will pick different random numbers. All right. I'm getting tired of this random seed business, but okay, what's your random number? 1, 2, 3, 4, 5, 6. Okay, cool. Seems to be working. All right, I'm going to pause it, make sure that we're all together. This would be a good time to take a break. Why don't we come back at 8:15? All right, gang, if we wanted to modify this to have it tell us, let's make a few modifications. Let's just make a list. Make the max number 100, not 10. That'd be easy. But to make that better, 110 are magic numbers in effect. Let's define the max as a constant so that we can just change it, you know, like up at the top of the code or something like that. And then what else would make the game more fun? What if we're picking a number between 1 and 1,000,000? I don't want to have, I want some clue as to whether I'm supposed to go up or down. So print a message saying if the guess was too high or was too low. And then D, maybe keep track of how many turns we've played. All right, so that's my goal. Making the max number 100, not 10, is easy, right? What would I change? Obviously, I'm going to change that, right? And then I'll probably change my comment. I ought to also change that, though. So if I was going to define that number as a constant, I'm going to show you something. We haven't really talked about it yet, but I could come up here and there's another preprocessor command called define. So way up at the top of your program, do this. Define max underscore guess as 100. That doesn't even look like a variable. It's a preprocessor definition. In previous versions of this class, I haven't talked about the preprocessor, and I'm going to this semester because it's pretty important, actually. And just because the book doesn't hit it doesn't mean that we're not going to hit it. Okay, so add that line up to the top of your code somewhere. It could be the very first line, but I'm just going to put it above main. Then go down here, and in our area where we were playing our game, where we were using our secret number generator, where it says secret is equal to 1 plus secret %10, change that %10 to max underscore guess. And I may as well modify that comment too. Max underscore guess. But I better modify my print statement as well, because it's no longer between 1 and 10, it's between 1 and the maximum guess. We could have even asked the user. But okay, so I'm thinking of a number between 1 and, I'm going to comment, I'm going to delete that stuff. So now it says 1 and space semicolon. So I just changed that line, and I'm going to tack on another line. C out, arrow, arrow, max underscore guess, arrow, arrow, double quote, exclamation point, end quote. Oh wait, double quote, exclamation, backslash, end quote, parentheses. Okay, so these are the two lines that I have modified now. So when I run it, I think I set the max equal to 100. I'm thinking of a number between 1 and 100. Okay. I'm not going to actually play the game, because without it telling me whether it's less or greater than. I would like for y'all to tackle that on your own, just for about 5 minutes. What I would like for you to do is to modify the code to tell you if the incorrect guess is too high or too low. That's your challenge if you choose to accept it. And if you can't figure it out, I am going to show you. It's not too hard. Alright, so just out of curiosity, how many guesses at most would it take for us to figure out a number? There's a formula for it. It's going to be 6 or 7. We can kind of figure it out also. We're going to just pretend that by using the optimal formula, we're going to see the worst case possible. And I'm just going to type them out. Okay, so say that it said between 1 and 100, so I said 50. And it said go higher. So I said 70. Now I'm going to say lower because my brain works better that way. Then 25. And it said lower. And so I guess 12. You have to pick either 12 or 13, right? Because we're dividing it by half each time. Lower. 6. Lower. 3. Lower. 1. Well, how many guesses? Okay, I think that's worst case. 1, 2, 3, 4, 5, 6. Doesn't look like it is absolute worst case. I think it might actually be 7. But 6 or 7 guesses should always get you the answer if you're doing it with this greater than less than business. That's called a binary search algorithm. Not binary as in zeros and ones, but binary because you're chopping the list into 2 pieces each time. And that's a concept that we'll probably get back to later when we're talking about arrays. So what if it was more than 100 elements long? What if it was 1,000 elements long? What would be the maximum number of guesses? 9 or 10 guesses would do it. That's pretty wild for a number between 1 and 1,000,000. 1, 2, 3, 4, 5, 6. How many guesses would it take? That's still a surprising number to me. That if somebody's thinking of a secret number between 1 and 1,000,000, you ought to be able to get it no matter what within 20 guesses. And probably smaller than that, you know. And what I don't know what the average would be. I don't know the formula. That's the max. So binary searching is a nice thing. Because otherwise I'd have to guess, you know, like we were originally. When we did 1 and we went up to 10, that's a linear search. You start at 1 and you keep going until you find it. And the maximum of that is the maximum value, right? It might have taken us 10 guesses. If the number is between 1 and 1,000,000, then it could conceivably take 1,000,000 guesses to find it. Here the maximum number is like 20. 20 guesses will find it if you're able to do a binary search. Binary search does have a requirement though. The requirement is that the data be sorted. Fortunately, our guess range is sorted, right? 1 to 100 is easy to figure it out. But if you have like a million names and you're looking for exactly one name, if those names are sorted, you can do a binary search on that list of names and it could find it, you know, within 20 hits, 20 reads. Whereas if it wasn't sorted, you'd have to just start at the top and keep going, and it might take 1,000,000 reads. So a binary search is a good thing, but the data has to be sorted. It's kind of an aside. I don't know if we need to do this other one, just keeping track of how many turns we have played. Did anybody need help doing the higher or lower business? Okay, just a sec. So the question is, how do we stop the program from going nuts if somebody types in a letter or a word rather than a number? Well, let's just play with that idea. I'm going to just do a while parentheses true, and in there I'm going to do cout, enter a number, period, space, space, quote, and I'm going to declare a variable int x. I'm going to cin into x, and then I'm going to see out what they typed in. See out less than x, arrow, arrow, endl. That's a dumb program, right? It's just going to go forever, but that's okay. As a matter of fact, let's take that code and snip it and move it to the very top of our code so we don't have to play the game before we try it out, right? So I'm moving all of that while true business up to the very top as the first line of code after main in my curly brace. Enter number 1. Enter number 2, 3. What if I type in A? All right. So it's in an error state. When I hit Control-C to stop it, it's asking me what I want to do. Do I want to break it? Do I want to whatever? I'm going to click break, and then I'm going to click debug, stop debugging when it gets into that state. Okay. So what can we do to fix that? It gets into an error state where CIN is failing, and this website that I hit says that we can call cin.clear followed by cin.ignore. Cin.clear resets the error flag, and cin.ignore empties the buffer. Now let's give that a shot. So above the cin statement, we're going to add in cin.clear, parentheses in parentheses, and then cin.ignore up to like 100 characters that they typed. It's probably a way overkill, but we're going to do that. I wonder if that's going to fix it. Enter a number. 5, 6, 7. Well, okay. Yay. I probably shouldn't have been ignoring that. I'm going to change that to just ignore 1. Huh. Sure is not what it was indicating there. Okay, and then there are more complicated ways of handling it. One is to use what's known as a string stream. You can read it into a stream string, and then you can try to get it out of that stream. Okay, well, they're going off the rails there. How about we do this? While not cin.fail. And I'm going to take that clear and that ignore out. Nope, that didn't work. Okay, it's probably a function call. Enter number 456A. Well, it's certainly not correct. Can I just do cin.clear there and have it magically fix that? Nope. All right. Cheapest of all solutions. I'm going to change that back to while true. I'm going to get the input in, and then I'm going to do if parentheses cin.fail open parentheses, close parentheses, close parentheses. I'm going to display an error message, and we're just going to quit. Cout. Sorry, bad input. \n. If you're using Windows, add system pause and then do exit. exit 1. I know we're doing some stuff that we hadn't really seen before, but that's okay. What exit does is it kills the program. We could have used return just as well, but exit totally kills it, whereas return, if we were inside of a function, it would just return out of that function.
So could we do if C and fail and then have it clear the buffer inside there and tell them to try again?
That's one of my guesses, is we could try that. That's where I'm going to go next. Okay, good. I'm happy with that. Now, instead of pausing and exiting, let's try that. cin.clear, cin.ignore. Dude, that does it. Good job. Okay. All right, I am happy with that solution. I'm going to delete those 2 lines. We could put this in a function so that we could call it every time we want a number. And I kind of feel like doing that. And you could use this function anytime you wanted to read in a value. So, I don't want to start hacking and slashing until everybody's got this. Is it working for everybody at this point? Pardon me? It is?
Yeah.
Okay. Anybody need?
I don't know, because this is giving me all types of things over
Take the semicolon out. F. No, you don't have a semicolon there. Rebuild it. Do.
here. Oh, wait a minute. So it's not CIN fail?
Let's change that back to true. While true. All right, now let's rebuild it.
What's that?
You're going to need an opening brace before the word while.
I'm trying to read my code for the game.
So before the word while, put an open brace. Hit enter, just to format it pretty. Okay. Now if we have a closed brace, delete that closed brace. Oops, I should have touched it. Delete that closed brace and that open brace.
Where?
That one. There's another. Okay. Now build it. Top one.
Which one?
Just can't see it. Yeah. Parentheses in parentheses after the word ignore. All right, build it again. Double click it. Well, if it doesn't like redeclaring it,
Take it out.
just take out the word, yeah, just take out the word int. I don't care about that argument conversion. What's the next one? Okay, double click that one.
Can you get rid of this one?
No, gotta have that one. Maybe we don't have enough closing braces. This is dumb. Or maybe we have too many closing braces. Build and see. Okay. Well, that's not good. There's something wrong with it, but that's okay.
Sorry.
Okay, I'm gonna stick my face in your screen again. As a matter of fact, I can hit the control key and spell it too well. Never put a semicolon after a close statement. Breaks the code. Alright. Maybe we'll do, sure.
Okay, so what I want to do is I want to write a function that we can use every single time. In fact, let me start the recorder again. Oh, great. It's been going. Okay, sorry, guys. What I want to do is I want to write a function that we can use over and over and over to get input, and it'll have this error handling in it. Now, we're not going to, this while true, I'm not sure if that's exactly how we want to do it. But I'm going to cut everything from while true. So I'm going to put my cursor here in front of while true, and I'm going to hit the down cursor all the way down. The CIN.clear probably doesn't have to be there. I'm going to wind up deleting that line in a minute. But anyways, highlight all that, cut it, and then come up here and let's make a function called getInt or CINInt or something. Let's come up with a good name for it. INT space get underscore INT parentheses in parentheses open brace, paste all that stuff. Now we're going to make a change. We don't want it to loop if we've got good input. We want it to return if we've got good input. So I'm going to stick a return statement right here. I'm going to replace that cout arrow arrow x arrow arrow endl line with return x. We could optimize, we could change the logic so it was a little more traditional. While trues are not traditional logic. I like them, but they're not traditional logic. Okay, so let's scroll back down. Has everybody got that done, this part done? I don't want to get this off the screen until you're ready. Whoops. Just make sure it compiles at least after you've made those changes. We don't have any code that'll actually test it, so we can't prove whether it's going to work or not, but I want to make sure it compiles. So build, rebuild solution. Anybody need us to slow down, or is this good? Okay. All right, so above main, let's delete that sin.clear. I don't think we need that. But let's display a message, cout, type a number, \n, end quote, semicolon. Now let's declare a dummy variable just so that we can prove that it works. int space dummy. And then dummy equals get underscore int, parentheses in parentheses. And just to make sure it worked, let's print out what we typed. So after dummy is equal to get underscore int, parentheses in parentheses semicolon, let's cout dummy number is space end quote arrow arrow dummy arrow arrow endl. All right, enter a number. Okay, that worked. Now let's type in some wrong data because that's the proof in the pudding, whatever that's supposed to mean. Let's enter a number. Let's type in A, and it says, sorry, bad input. Not really what I wanted to see it do, so I must have put my return statement in the wrong place. I'm going to go back in and make a couple of changes. One, I'm not real fond of that enter a number being repeated every time. This should be an else, right? Because if we do that, then we print out an error message, else return. And I forgot to do the else in front of it. So I'm just going to type in else return x. All right, type a number, enter a number. I don't like that double quote, that double input. double prompting. Sorry, bad input. Enter a number. Okay, it's working. I like that code. You could copy and paste that into all your projects, and anytime you wanted to get an int, you'd be writing an error-free version of it, right? I mean, not an error-free, an error-handling version. If you wanted to make a version that did doubles, you could just change the return type to double and call it get double, and then change that variable to get, int double x. I don't feel like we need to do that. If this has clicked with you and you think it's cool, that's fine. If it hasn't clicked with you and you're kind of rolling your eyes up at it, it's okay.
Can you go back down to the dummy?
Sure.
How are you calling?
So here we go. Here's where we called it.
Just returning X to those parameters and putting it in dummy.
We could pass our string inside. So, pardon me?
Sorry, I was just,
No, please repeat. Tell me what your suggestion was.
it wasn't a suggestion, I was just stating what it did.
Oh, okay. Yeah. One last nice thing I would like to be able to do is, instead of printing a message that said type a number and then and having it repeat that, enter a message, I think I'm going to cut that, paste it into getInt, and we're going to have to modify the getInt function to accept that argument as a parameter. So we're going to have to go and modify getInt to accept a string. So up here, getInt needs to accept a string, so as its parameter, inside the parentheses of the getInt line, string space MSG. And then where it says cout enter a number, let's print the message instead. So I'm going to change that line now to cout message. Then I'm going to scroll back down to make sure I haven't introduced any errors to my dummy code. So I changed that line, and I changed that line. Don't add these comments. You know why I put them there, just so that your eyeball can zero in on them. Scroll back down. Dummy is equal to get underscore int, type a number. Okay, gonna run it. All right, type a number. I'm gonna hit some invalid input. Dude. You know what it's doing is it's looping once for every bad piece of data. I think that's acceptable. I'm not going to worry about it any further. If you feel like it, you could research how to get that to work completely. Everybody got it working, or need?
Well, I have a small.
Okay, let me come look. This little business where when I run it and I type in a whole bunch of bad characters and it displays a whole bunch of error messages, I think I ignored part of the suggested solution on the internet, which was cin.ignore, and then first type in a huge number, but also just type in comma/n. But that didn't work. It's highlighting that as an error. Let me go eyeball it one more time. Oh, single quotes. Single quotes around the \n. And is it really a \n? Let me eyeball it one more time. Yeah, okay. Maybe that'll do it. Okay, I am happy with that code. I'm going to want to enshrine that. I hope it kind of makes sense, but I know that we're doing some stuff that we haven't hit in the book yet. Hopefully you do remember this from prior classes or whatever, what defining a function means, you know. We are doing more business with CIN than I'd ever expected us to do, but on the other hand, it had always nagged at me to introduce the idea of error handling, and I never really had. So I'm glad you asked that.
So you said we could use get int anywhere through the code. Do we have to put that function in there for that while loop to do it?
If you want to use this in any other program, you're just going to copy and paste this into your code, into your
once?
new program. Right?
Yeah, so just once?
Yeah, right. And then if we want to fix the rest of our code to use this as well, like down here where we ask for the seed, let's change that. Where it says, what is our seed? Do this. Instead of CIN arrow arrow seed, change that line to seed equals get underscore int parentheses, and if you made it accept a message, great. Enter a whole number. And you could replace all of your CIN statements with calls to get INT. And it would make your program far more bulletproof. What is our seed? I'm going to type in bad data. It says, sorry, bad input, enter whole number. Okay. And there's one more place, right, where it says, what's your guess? I could replace that as well with the same kind of business. Alrighty. Did I break the code for anybody, or are we good to go on? Wave your hands if you need help. Okay. Alright. Well, now that we've made it 2 pages into the PowerPoint, I'm kidding. Okay. Hand tracing a program. That's when you're playing like you're the computer. And I'll give you an example. We need to write some dummy little program to follow. And it is going to involve a while loop because that's just how it is. Okay, int x is equal to 1. While, parentheses, x is less than 10. Right, don't type this in your code. This is just going to be an example. So here we go. While x is less than 10, let's say, let's declare a new variable. Int z is equal to 2. And then z is equal to z times x. And let's see out. Now, we're not going to even see out anything. And then x plus plus. There's our dummy little program. Who cares what it really does? I just need something to hand trace. And rather than get on the board and write, since people may be watching a video, I'm going to do this with Excel. What I need is to set up a little bit of a grid that I can follow. So I'm going to create some spaces for the numbers. I'm going to need a place to keep track of x, and I'm going to need a place to keep track of z. So when the program starts, what's the first thing that happens? X changes to a 1. Then what's the next thing that happens? Z goes to 2. Now I'm not going to put 1, 1, 1 every single time in there. I'm only going to put a number there if that variable actually changes. Can I center all this real easy so that it doesn't look so bad? Okay. So when we go to the next line, z changes to 2. And then we go into here, while x is less than 10. Does anything change? Nah, so I'm not going to write anything. Is x less than 10? Is that a true statement? Yeah, so we're going to enter the loop. Z is equal to z times x. Well, z is equal to z times x. 2 times 1. So z still changes to 2. It stays 2, but I am going to go ahead and do that because there was supposed to be a calculation there. And then x plus plus, so x increases. All right, and then we loop back up. Is 2 less than 10? It sure is. Now we're going to do this again. Z is equal to z times x. Well, 2 times 2 is 4. And then we increment x again. And I'm going to change this to 3 because I really don't want to go 10 times. Okay. No, it didn't become 2. We added 1 to it, so it became 3. Is 3 less than 3? No, that's false, right? 3 is not less than 3. And so that's when the program stops. We have hand traced the program by writing down the variables, stepping through it line by line, and watching as the variables change. We have the world's most awesome programming tool, so what we would probably really do is to enter it, set a debug by clicking on the margin, and then doing local Windows debugger, and then you could use these little symbols here to watch what happens. I'm going to do step over. I'm going to type something in because that's what it's waiting for me to do. Each time I want to see what it does next, I'm going to keep clicking the step over symbol. I'm curious about what X is, and so I'm going to hover my cursor over X, and it tells me that X is 67. So the debugger works the same way as that hand tracing business. And if you go over here to autos, it shows you all the variables that are currently in scope. We only have one variable in scope. I'd like for y'all to all give this, I think I just closed some windows I really didn't want to close. I'm going to hope that they come back as soon as I start the debugging again. They do. Okay. I would like for y'all to all play along. Let's write some new code just to watch the debugger go. Let's declare some variables. Int x1, comma, x2, comma, x3. Let's assign some values to them. x1 is equal to 2. x2 equals x1 times 2. x3 is equal to x2 times 2. That ought to be enough to prove the point. So I'm going to set a breakpoint on this line right here. Go ahead and Control S it. Make sure everything's saved. Then click on the border here and put a breakpoint there. And it says the breakpoint will not be hit. The source code is different than the original version. What's happening is I'm currently in a debugging session, and it doesn't like the fact that I edited it while I was in a debugging session. I need to stop the debugger. See, the program is still running. That was my mistake, and I'm not going to hit close. I'm just going to stop debugging by going up to debug, stop debugging. Now my breakpoint is there. So click local Windows debugging. It'll run to that point. We have 3 variables defined. So if I come and I look, well, I'm not seeing my autos. Pooh Bear. Find this little symbol, the one that says step over. If you can't find it, just find it under debug. There's debug step over. But does everybody have that on their screen? The semicircle with the dot in it that means step over? Has anybody found it? Okay, if you can't find it, right click on the toolbars and make sure that the debug toolbar is enabled. You can disable the debug toolbar and you'll watch it disappear, and then you can re-enable it and you might be able to spot this stuff. I think it stopped the debugger. Let's do start debugging again. Okay, it's right there. Yeah. Don't do step into, do step over. And you can see that it went to the next line. Everybody find step over?
I understand.
Oh, okay.
Oh,
Yeah. Yes.
I got it. Thank you.
All right. If it displays all this rigmarole, go to debug, stop debugging. All right. Now let's try it again. Local Windows debugger. Sorry. Yes. Looks like we have some errors. We never want to hit yes when it says that there's errors, because then it goes nuts. So stop the debugger. Do build so that we can see what the error list is. There's the top error. Oh, yeah.
disk.
Yeah.
Okay,
Wait a minute. No, I was just putting commas in there because I was.
that's cool. We need
Oh,
int.
okay.
Yep, you just need one at the very end. Yep,
Alright.
let's try a rebuild. Okay, now try running it. Okay, there's the debugger. Find the next symbol. Step over. Yep, click that. You can see it goes to the next line.
Okay, so as it goes over the next line, you can hover your cursor over it and see what it changes the values to. I'm going to step over another statement, and I can move my cursor over here, and it says that x1 is equal to 2. Sure enough, it is, because I said so on the prior line. x2 doesn't have a value yet. If I hover my cursor over x2, it's just got some garbage value, because it's not initialized. So if I hit step over again, now x2 has a value. I can move my cursor over there. Now, I really wanted to be able to see my local variables, my auto variables, and I'm not seeing those. Window, debug. I'm not going to spend any time. Does anybody have the word autos down here? Is that a yes? Did I hear a yes? Okay. If you click on autos, you're going to see all the variables that are currently in that scope. The autos window, Control-Alt-V, or debug Windows autos. Okay. So debug Windows autos. There they are. And you see x1, x2, and x3. x1 has a value, x2 has a value, x3 doesn't have a value. So if I hit step over one more time, then now x3 does have a value. It's interesting that all of a sudden my other autos are no longer listed. Not sure why that would be. I'm going to stop the debugger. I'm going to click debug, stop debugging. I'm going to take that int dummy and I'm going to move it up here to the declarations. I'm going to run the debugger again, and I want to see what the autos window is. Okay, there they all four of them are. I'm not sure why it disappeared when it got past that point. You can see that it's only keeping track of the most recently changed ones. That's not right. Okay, I'm not going to spend any further time on it. That's how you solve problems. If your code isn't working right, you set a breakpoint, you start debugging it. What if you need it to go into a function? What do I mean by that? Right, we have this function getInt, but it's going to step over it if I'm not careful. Right, so I'm going to click that, and that's why it's called step over. Step over, step over, step over, and now it's highlighting this line, getInt. I sure wish it would go into it, but if I click step over again, it skips it. Well, it doesn't skip it, it runs it. And now I have to come back here and it's got the result. Dummy, I typed in 56. I might want to actually go into that. Yeah, there's more than one way. I could set another breakpoint right here inside getInt, or stop debugging. Step over, step over, step over. Now I'm going to call my function step into. That gets me inside the get_int function. And that's not what I was expecting to see. I'm going to step out of that with this thing. And then I'm going to do step into again. Alright, now I'm in the getInt function. It probably would have been better to set a breakpoint there rather than to mess with that. But step in causes it to go into the function that the current line is highlighting. And if you don't want to watch that function run, then you can do step out to get back out of it. And we're going to do that again because I want y'all to become experts at debugging. For now, I'm going to do debug, stop debugging, and I'm going to remove all the breakpoints so that as I keep running the program, it doesn't keep doing that. If you need to see a list of all your breakpoints, you can do that. Like say I have one enabled and I can't find it. When I run the debugger, I should have a breakpoints window. I'm not seeing it, so I'm going to go Debug, Windows, Breakpoints, and it'll show me what line number it's on, 35. I could probably disable it right there. Or I could just come over here and click it. All right. Hand tracing a program, we've done it. Their program was more complicated than mine, so great. They had 4 variables to track rather than 1 or 2. Do you have to set up an Excel spreadsheet to do it? No, you can just do it on pencil and paper. A case study. This sounds like something we're probably going to quit, leave, ignore. Nah, we're not going to ignore it. General Crates Inc. builds custom designed wooden crates. You've been asked to write a program that calculates the volume, the cost, the customer price, and the profit. Alrighty. The program must perform the following steps. Ask the user to enter the dimensions of the crate. Dimensions would be height, width, and depth. And then calculate the crate's volume, the cost of building the crate, the customer's charge, and the profit made. And then display the data calculated in step 2. This is not showing us how to calculate the cost. So the following formulas will be used to calculate the crate's volume, cost, charge, and profit. We know how to calculate the volume. But here's what I was wondering about. How do we calculate the cost? The cost is equal to the volume times 0.23. And then the charge is equal to the volume divided by 2. I don't know why they made it times 1/2 when you could word it as divided by 2. But whatever. Leave it like that. And then the profit is equal to the charge divided by the cost.
Is it minus or divided?
Minus there. Something looks wrong to me about this. And what looks wrong to me is that we could calculate profit without calculating this intermediate step in one swoop. What do I mean by that? And I'm just being...
Well, we have to display both.
Yeah, if we're going to display them, then we would need them all. But what I was thinking is that you could replace that with that. You could replace cost with that. You could rewrite it like this. Sorry guys, I'll undo all that. That would be how you could calculate it, but we're not going to do that. Okay. Okay, so this is the really important page to me, because we know that we need to ask the length, the width, and the height. The rest of it we could figure out how to do. This sounds like a good enough thing to code, and I think it'll be the last thing we code for today. Probably. I should just make y'all do it, but maybe we'll do it together. Okay. Again, as always, I'm just going to stick it up at the very top of my program at main to make it easy to spot. Alrighty, so this is my pertinent information. I'm going to just stick it up here in a comment, so I have it available to me. When I copied from the PowerPoint and pasted it into the C file, that apparently wasn't a great thing to do. It complained that there was a non-ASCII character in it. Okay. So what are we going to have to do? Our pseudocode. We're going to have to ask for the length and the width and the height. Let's tack on some pseudocode. You don't have to type what I typed here, but I would kind of like for you to flesh out the pseudocode. Input, length, width, height. And then calculate cost. Calculate charge. Calculate profit. And then show those three things. It looks to me like we should use doubles. Why do I say that? Because we're multiplying times 0.23 and 0.5 and stuff like that. So let's just declare all of our variables in one fell swoop. Double space length, comma, width, comma, height, comma. Maybe I'll put the next line on the next semicolon. And then double space cost, comma, charge, comma, profit, semicolon. I'm going to hard code those values, length, width, and height. But then I'm going to ask you to come back in and actually prompt the user for them. So length is equal to 10, width is equal to 20, height is equal to 30, and I'm going to put a comment, fix me. We're not going to want to do that in the final version. We're going to want to, read in from prompt the user for it. All right. Now we can just use our little equations. Cost is equal to, wait, I never calculated the volume. We're going to need another variable for volume, and I didn't declare one, so I'll do it now. Double volume is equal to length times width times height. Now I can use cost and charge and profit. I thought I was being clever by declaring all my variables up at the top, but I forgot volume. Cost is equal to volume times, and what's the conversion ratio for that? 0.23. The charge is equal to the volume times 0.5. And then lastly, the profit is equal to the charge minus the cost. Charge minus the cost. And then C out results \n. I'll make y'all do that as well. I'm going to go back and put in a comment here. Prompt the user for the length, comma, width, comma, height. I better display the profit. No, I can just put a breakpoint there and see if I think that it's working or not. So I'm going to do stop debugging because I did leave the debugger up. Going to run it. Type a number. Okay. 12. It displayed the results. It didn't actually stop at my breakpoint because my breakpoint's gone. Let me reset it. I'm going to set a breakpoint here at the results because at that point it will have done all the other calculations required. Okay, so what's our profit? 1,620. What's our charge? 3,000. What's our cost? 1,380. All right. This will be the last thing I want you to do today. And I'm actually going to make this a homework assignment. So I'm going to make a Dropbox for the in-class and then fix this code so that it works. How do we fix it? Ask the user for the length, width, and height. You could use our new function, or you could just use CIN, arrow, like normal, and C out. And then display the results. Show them the charge and the profit. That makes sense to run up to the point where you got it running at this point, no syntax errors? Okay. If you feel like it, you could stay here and work on it before you left. And, it's probably only going to take you 10 minutes or whatever. But if you feel like you're just running out of here, 30 minutes early, then you don't have to do this. This is a kind of a roll your own section. All right, let me make a Dropbox for the in-class stuff.
So when you do the Dropbox for the in-class, you want our files that we work on in class?
Sure. Yeah. Whatever you did for that day, and even if you didn't get it working, and if for some reason you're here that day but you lost your file, just upload a note saying you were there that day. That's kind of how I keep track of attendance. All right, so there is a Dropbox D. Now, refresh your assignments and you can upload your CPP file, but I'm also going to make a homework 3. And when you get your program done, if you're not already done with it, upload it there. And I will be glad to help y'all. But I'm going to return the recording off, so if anybody missed, they have to do it themselves. All right, I'm going to close the window while I type up the homework assignment. Alrighty, that's enough.